Hi, everyone. Welcome to week three's lesson in our Prep for Pre-AP Precal Semester 1 course. So what we're going to talk about this week is we're going to review as much as we can about linear and quadratic functions, equations, solving for them, graphs of them, attributes of them, tables of them, everything that we can, even regressions using the statistics calculator in Delta Math. So linear and quadratic are things that you're expected to be experts on already. You studied them in Algebra 1. You studied them in Algebra 2, although linear not as much because you spent the bulk of your time in Algebra 1 talking about linear functions. So I'm going to review you now. You'll also get a very short review, maybe like a couple of days total, to review it with your pre-cal teacher, and then you will move on and you'll be expected to remember that stuff because you've known it for so long. So what we're going to do is just start with linear and then move to quadratic. So the first thing we need you to be able to do is identify a linear function or a piece of a linear function. If you were to look at this graph right here, I think you notice this is a piecewise function. It's like four separate, like here's a line, here's like part of a parabola, here's a line, here's part of a parabola. Can you tell me which piece or between what x values do we have a interval where the function is increasing and linear? So I see two linear pieces here and here. This one is a decreasing linear piece. This one is the increasing. So we're interested in what are the x values represented by the endpoints of that linear piece. And if you look at it, it is the x values of -9 to -4. And so that is the answer that we would choose. Between the x values of -9 and -4, we see an increasing linear portion of this function. All right, we can't talk about linear functions without talking about slope and rate of change. Those are pretty much synonyms for one another. Usually rate of change has a little bit more to do with units, like real life examples of linear rates of change would be dollars per hour, like what you get paid, or miles per hour, how fast you drive a car. Slope itself usually doesn't have units, and rate of change does not always, but usually you'll usually see that. You can find rate of change or slope from a table, from a graph, from a couple of points. You only need 2 points to find slope or rate of change. So if we have a table, the quickest way to find the rate of change, especially if you already know that it's linear, is look at the change in the y's over the change in the x's. Now, if I look at these y's, -4 to -3, that just increased by 1. 4 to 8 is an increase of 4. So +1 over +4 is the rate of change or the slope. So 1/4 would be what I would write. You could write 0.25. That would be correct. You can use a decimal as long as it's exact. If it's a repeating decimal, that's not exact. You need to use the fraction to represent that. All right, if you have a graph, you would see the grid lines much better than you can here. But I think if you look, you see that the y-intercept of -1 and the x-intercept of 1, those give us our rate of change or slope. It goes up 1, it goes over 1. So up 1 and right 1, those are both positive moves. So that would make the slope equal to just 1. Identify the rate of change. That's all they wanted was the slope. Okay. There is a section on this topic where you actually have to kind of plot the vertical change versus the horizontal change. So you would, in this problem, it says draw a line representing the rise and a line representing the run. So they're basically going to have you look for a couple of points and draw the rise and the run, these two little pieces, and then classify what that is as a slope. That's up 1 and right 1. Those are both positive. So the slope is 1, and that's what you would write in. But they do expect you to show those pieces of rise and run that got you that number. And then, of course, you could always just be given an x and a y, another x and another y. It could be given in a table form. It could be given as just a list of ordered pairs. But you can always find the slope. This is on your star formula chart from Algebra 1. You've learned about slope in 8th grade math. Subtracting the y's, that would be 5 minus -3. Subtracting the x's, -9 minus -3. Minus negatives always turn to positive, so I get 8 on top and negative 6 on bottom, which reduces to negative 4/3. That would be my slope. And that is simplest form. Don't write negative 1.3. That is not the same. This is negative 1.333 repeating, so you have to write it as a fraction if they don't give you permission to round. Now, average rate of change. I include this because average rate of change means it's not the rate of change of the entire function. In fact, the function may not be linear from start to finish. But between any two given x values, we can find an average rate of change. And again, we're not saying it is of the entire function, but it represents the relationship between those two parts of the function. So here they give us a function in a table. It has x's of 2, 4, 6, 8, 10, and it has y values of 41 all the way down to 21, 9, 5, or 3, and back up to 9. It is asking for the average rate of change between the x values of 2 and 10. So we are literally looking at this point and this point, the x value of 2 and the x value of 10, and we are ignoring all the rest of these. And we're focusing on how did the y's change. I went from 41 to 9. That's a loss of 32. My x's got bigger from 2 to 10 as a difference of 8. So the average rate of change, I'm not saying that the entire function has this rate of change, but from the starting point to the ending point, it had an average rate of change of negative 4. And that's all you're representing there. You're not saying that this is linear or that this is the slope of this relationship. You're saying that that's the rate of change between the beginning point and the ending point. Now, it may not always be the beginning and end. Here on a graph, it says find the average rate of change between the intervals of x being 1 and x being 2. So if I go to x equals 1, here's the point that I see, and that is the point 1, negative 15. And then for 2, I see the point 2, negative 10. And so I just want to find the rate of change between those 2 points. You could even put them in a table. 2, negative 10, 1, negative 15. It doesn't matter which one you put first. So what's the change in the y's? It loses 5. What's the change in the x's? If I'd written it in this order, it loses 1. So the change in the y's over the change in the x's would give me an average rate of change of 5. Obviously, that's not true all the way through. This is a negative rate of change. It's positive, and it's going to be negative again. But between these 2 points right here and here, that is the rate of change happening at that particular part of the graph. All right, we're done with that page. Next thing we're going to look at is one more average rate of change. Can we compare rates of change? So if you look here, I've been given a piecewise function, and there's 4 distinct pieces here. We're looking for which interval of x is the average rate of change the smallest. So rate of change is a slope. So basically between which points, 0 and 1, 1 and 5, 5 and 7, or 7 to 12, which one of these has the smallest rate of change or the smallest slope? And it doesn't matter whether it's pointed positive or negative. It just matters on how steep it is. So if I look at this, I can clearly see that the average rate of change that's the smallest would be the least steep section of graph. And it doesn't matter whether it's negative or positive. Okay, so I just want to make sure I can look at this and go, without a doubt, that is the least steep portion. Now I can back that up with numbers. I could do a slope formula on these 2 points, on these 2 points, on these 2 points, and on these 2 points, and I'm going to find that this is the smallest slope. So that is definitely what I'm going to choose. And I can prove that just if I look at the y's, they go from 13 to 16. So I'll go up 3, and then I go over from 7 to 12, 5. So the slope there for that piece is 3 over 5. That will be smaller than this slope, and this slope. So we're definitely going to pick that. Now let's remember, writing linear functions, there's lots of ways to write linear functions. The most common way is the slope-intercept form, remembering that the m represents the slope and the b represents the y-intercept. In word problems, the y-intercept is always your starting value. Okay, on a table, it's the y value that has an x coordinate of 0. So you can find that. If you don't have that on a table, it is still easy to find. As long as you have 2 points, you can find the equation of a line. So we look at this first one. We're given a linear function. They tell us it's linear. I see a point that starts with 0, so I already know that this is my y-intercept, 8. This is going to be what I put here. And then to find the slope, all I need to do is find the change in the y's over the change in the x's. So the slope is that my y's change by 6 for every 1 change in the x's. So my slope is 6. So I know that my equation is going to look like this. The slope is 6, the y-intercept is 8. I'm done. Now I can do that even if I have a table that doesn't have a 0 to start. I can easily find the slope, and I can find that between any 2 points. So if I want to find the slope, the y's increase by 3 when the x's increase by 3. So the slope is 1. I don't see the y-intercept, but if the slope is 1, then that means every time I change the x's by 1, the y's are also changing by 1. So I could look at this and go, okay, after -1, that's where 0 would fall. And so what's 1 bigger than -5? -4. So there is my y-intercept. And now I can write my equation. Y equals 1x, or just x, minus 4. And that would be the linear function represented by that table. Now, let's talk about if you're given a word problem. Haley was given a box of chocolates for her birthday. Each night, Haley treats herself to some chocolates. The number of chocolates remaining in the box, T days after her birthday, is modeled by this equation. So the number of chocolates left equals -4 per day, because she's eating 4 per day, per night, plus 24. 24 is the y-intercept. That is the starting value. So that means when she received that box of chocolates, 24 means that's how many chocolates she started with. Or how many were in the box when it was given to her, right? Here's another chocolates problem. Tristan was given a box of assorted chocolates for his birthday. Every night he treated himself to some chocolates. Let's C represent the number of chocolates remaining in the box, T days after Tristan's birthday. This is a graph of that function called C. Write an equation, then state the slope of the graph and interpret it. So if you look at this, we start with 30. So the y-intercept is 30. That's how many chocolates were in Tristan's box, right? And then if we notice, we can see that it looks like every day there's a new amount here. Looks like there's supposed to be one there. I would even just go to the end and be like, okay, by day 6, there were 0 chocolates left in that box. On day 0, there were 30 in that box. So can we find the slope? I would say, yes, we can. We can always say, okay, we started at 30 and by day 6, we had none. So my slope is that the x's changed by 6 and the y's decreased by 30. So my slope is that the y's decreased by 30 for every 6 increase in the x's. And that gives me a slope of -5. So I can write my equation now. This is like my y equals -5 per day plus 30. And the slope of -5 reveals that Tristan ate 5 chocolates per night. Because it says he eats them at night. You could say per day. It wouldn't make a difference, but per night. All right. Now, when we talk about different types of functions, we have to remember about what the word correlation means. Sometimes our functions aren't perfect. Sometimes they look fairly linear or fairly quadratic. They might look fairly positive or fairly negative. Correlation is giving us is the word to describe that when we notice a type of pattern. It also relates to how strong a relationship is. So when something is, when you're looking at the strength of something, you could say it's strong, you could say it's weak. That's what we're doing here. So correlation refers to what direction and shape a set of data points has. It can be positive, negative, or none. A positive or negative correlation can be strong if the data points are close together, or it could be weak if they're further apart. And then there's also something called R, which is the correlation coefficient. You would be only given that if you're actually doing like a regression, trying to get an equation for a scatter plot. So if you're given one, and they're asking you to determine which is the strongest or weakest, you're looking at the R value. The closer that the R value is to either 1 or the opposite of 1, -1, the stronger it is. It will never go over 1 or below -1. If it's at 0, that means it has no correlation at all. If it goes towards -1, it's more negative. If it goes towards +1, it's more positive. Now, if we were to look at this, I want you to examine, do you see any trend here? I tend to think that this does have a positive trend, but I'm not going to say it's very strong. I believe this is a weak positive correlation. Yeah, I generally see the data points rising, but it's not organized at all. Whereas here, I've already been given 4 different regressions, and I'm looking for the one that is the strongest linear relationship. So if I look at these R values, that one's pretty positive, that one's a little bit negative. This one is smaller than -1. That's not possible. It should not be in the running. I said they cannot go below -1 or above +1. And then this one is really close to 1. It's way closer than this one, so this one can't be the strongest. So which one is closer to being a perfect +1 or a perfect -1 and be negative? And I believe it's this. This is the strongest correlation coefficient. It is closer to 1. This one is slightly further away from -1. So we're going to go with regression 4 as our strongest relationship. Okay, can we do a linear regression? You are being asked to compare the year since 2007 and the profits for a company. Doesn't say what type of company, but it does specifically say write a linear regression. Now, when we do this, we're going to round all the coefficients that we get to the nearest hundredth, and then we're going to use that equation to answer this question. In 2015, what's the projected profit? Rounding to the nearest $1,000. So what I'm going to remind you to do is to use the Delta Math Statistics calculator to type in the table and get the regression equation. So I'm going to come over here to the Delta Math calculator. When you go to the statistics calculator, you want to go to Edit Lists, and we're going to type in each of these X values using the down button to get from place to place. If you hit Enter, it's going to delete what you just typed in, and you'll be annoyed and you won't like that. All right, so we have all of these, and I hope I'm reading those right. Once I have them all typed in, I'm going to move to the calculator menu, and I'm going to choose linear regression. Notice I have linear, I have quadratic. This is not one that we use, and I have exponential, and we don't use this one. So I'm choosing linear. That's what they told me. I can turn the diagnostic on to see the R value, but I don't have to. All I want is the slope and the y-intercept, and these are they. It's a pretty good linear relationship. If you look at this R value, that's like almost 0.97. That means it's really close to being a perfect line, which is great. That makes your regression equation that much more precise. So I'm going to use that slope of 30.6 and the y-intercept of 58.4 to write my equation down. Oh, look what I did. Oh, okay. So I'm going to write down y equals 30.6. That was the slope, x plus 58.4. And then it asks, find the projected profit for 2015. Well, since 2007, that would be 8 years. So what I'm doing is I'm going to put in an 8 in for x, and I'm going to solve for the answer. And it says, write the answer to the nearest $1,000. So if we get this answer, I believe it looks like 303 something. Let me go to my Delta Math calculator. I'm going to do 30.6 times 8 plus 58.4, and I get 303.2. So we'll say $303,000. We don't need the 0.2, one of the nearest thousands. So 303,000. That'll work. Okay, now I'm going to take this back. All right, we're moving on to quadratics. So let's remember that the shape of a quadratic is called a parabola. We have a vertex, which will either be a maximum in this case, or if it was a happy face, positive parabola, the vertex would be a minimum. There's always a vertical axis of symmetry, which is an equation that you would write as x equals, and then whatever the x coordinate of the vertex is the end of that equation. There are up to 2 x-intercepts where a quadratic might cross the x-axis. It's not always going to cross 2 times. It may only touch 1 time. It could also never touch if it's already one that's too low or too high. It may not have any x-intercepts at all. It will never have more than 2 when it's a quadratic. The a value of a quadratic will tell you the information that you need about the direction that the parabola is going. This one is a negative parabola, so I know the a value starts with a negative. If this was positive, if I saw this, I would know that the a value was positive, and it also gives you an indication about the width. So if we look at this graph, it says determine the coordinates of the x-intercepts of the parabola. Down here, it's going to give you 3 choices. It's going to say 1 point, 2 points, and 1 equation. Okay, if it's asking you for the vertex, it wants you to choose 1 point, and then you're going to be able to list the coordinates of the vertex. If it asks you for the x-intercepts, then likely it's 2 points that we need to type in as answers. And you can write those 2 x values. Now that is the one that we're going with this time. So you would click this drop down, you would choose 2 points, and you would write -4 and +2. If it had asked you for the axis of symmetry, you would have chosen this selection off the drop-down menu, 1 equation, so that you can type in x equals and then write the x value of the vertex. So we're choosing 2 points, x-intercepts, -4, and then also 2. Remember, when you type in a comma in Delta Math, it opens the second answer box for your second answer. So if you type in a comma, it's going to give you another answer box, and that's where we can type in both values. Okay, so knowing what we know about A, the the coefficient, leading coefficient of a quadratic, it tells you what direction it's going and about how wide. Now I have 3 parabolas and I have 3 different A values, and I want to match them. I know for sure that these 2 should have negative A values, so it's right that they be here and here. The bigger the number, and I don't mean the negative sign, but if I have a 4 here versus a 1 here, 4, even though it's negative, should be narrower than a 1 for an A value. A 1 is a very middle of the road width, okay? Little tiny decimals will be wide, and bigger numbers, ignoring the negative sign, but just bigger numbers in general, will make a narrower graph. So I believe that this graph needs to be the narrowest. This one is kind of middle of the road. This one is the widest, and it is the only positive parabola. Since this A value is positive, it needed to go with something that looks like this. Now, you can find the axis of symmetry from any standard form. This is called standard form. It's an ax squared plus bx plus c form. And you can find the axis of symmetry equation this way. Negative the b value, which is this middle linear term coefficient here, over 2 times a. So in this case, I have negative b over 2 times a. And when I use my math to calculate that, I get -8. So my equation, and this is an equation, so it needs an x equals, this is a vertical axis of symmetry. All quadratics have them. I should write my answer as an equation. Now there's 2 forms of quadratics mainly. There are a couple others, but the 2 that we use the most, standard form, which I already talked about, and vertex form, which looks like this. Standard form, in both cases, A tells you what direction the graph's going and how wide it is. In standard form, this back number gives you the y-intercept of your graph. So that's important. None of the other forms give you the y-intercept. Vertex form is very handy because it gives you the coordinates of the vertex, the opposite of whatever you see in the parentheses with x, what's being squared. It's the opposite of that sign, and then it's exactly whatever the k value is. So first we're going to practice just putting a quadratic into standard form, and that means everything to one side. So I'm going to move both of these over to the left side so that I have equals 0 at the end. I'm going to start with the highest power. 2x squared plus another 2x squared would be 4x squared, then the 6x, then the plus 10 that I just moved over. And that is standard form. Also in standard form are the answer choices for this graph. Now notice, I should be able to look at this graph and know immediately that it's a negative a value. Okay, it's pointed down. So this cannot be right, and this cannot be right. These are my two choices here. Now, the other thing that I know in standard form is what the y-intercept is. If I look at this graph, can I clearly see that the y-intercept is -6? And I can see that that's true, and this is the right answer. Now, if I look at this one, these are in vertex form. Still, this is a downward-facing parabola, so I know that it's a negative a value. And I can also see, since all of these answers are in vertex form, I can clearly see that the vertex is -6, 2. So a negative a value would eliminate these two. That leaves these two, which are correct. And then I need to put a -6 into vertex form. If I put a -6 after a minus sign, that's going to turn this to a plus. So it needs to be this guy. And the positive 2 is exactly correct. It's always the same sign as the k value in the actual formula. Okay, we're almost done. One more thing that we need to review is how to complete the square. Completing the square helps us get from standard form to vertex form when we're talking about quadratics. It also, because vertex form gives us a vertex, and that's really nice to have, right? Because that's the middle of the quadratic. So in order to do that, let's just review what completing the square is. Where did I put my notes? When we complete the square, what we're doing is we are looking at this equation, and we're really just focused on these x's. I'm going to move the 35 even to the other side for a second. If I want to complete the square, what I'm trying to do is figure out what piece is missing from this side that would allow this to be written a different way. Like this. This is completing the square. So what I need to do to make that happen, to get this to look like this, and I'm sorry, that's supposed to be a 35. Why would I suddenly change it to a 32? I'm going to take this linear term, and you can only do this when this is a 1. So if this is a 1x squared, then I'm looking at my middle term, and I'm halving it, and then I'm squaring it. And that's what completing the square means. So I'm going to take half of 8, which is 4, and I'm going to square it, which is going to give me 16. So I'm adding 16 to both sides. The reason I do that is because that allows me to rewrite this trinomial as x plus 4 squared, and then over here, that's going to become 51. But the question's only asking which number would have to be added to complete the square. We added a 16 to both sides. Now let's practice doing that. I'm going to move this constant over here with the -9. It wants to know which of these 4 is the same as this guy. Now, when I moved -11 over with the -9 already over there, that makes -20. So what I need to do now is complete the square using this linear piece. So I'm going to take half of that, and I'm going to square it. That would give me -1, and -1 squared is a +1. So I'm adding +1 to both sides. The reason I do that is because it allows me to take this trinomial and write it like this. And over here, adding 1 to -20 is going to make -19. So we can see that the answer choice needs to be this one here that matches. 2 more problems. Can we do a quadratic regression? If we know that there's a rocket shot off a launcher, even if we don't see the data coming up and going back down, we expect that it will because we're assuming this is happening on Earth where there's gravity. Time is going by, the height is increasing. If it's quadratic, at some point, it's going to turn around and come back down. So we're going to do a quadratic regression using the Delta Math Statistics Calculator. So I'm going to take us back over there. You can always go back to edit lists and use these buttons to clear the X's and the Y's. So I'm going to write down or type out these X's and then same with the Y's. So 119, down button 233, 350, 447, and 574. And then I'm going to go to the calculator menu and choose quadratic regression and hit OK. Now that is gives you lots of decimals, but if you read, it says on your sheet of paper that you're supposed to write, it's very specific. You can always read this, a quadratic regression equation rounding all coefficients to the nearest tenth. So I'm just using one decimal place. So if I were to go back and look at those coefficients that they gave me, it would be negative 17.5, 249 whole, because it was like 248.9 something, which rounds to the nearest tenth, rounds up to a whole 249. And then negative 0.5 is your C value. We're going to use that regression equation to find the height to the nearest whole foot at a time of 3.8 seconds. So all I'm doing is taking 3.8 and plugging it in for x in both of those places and rounding that answer to the nearest whole number. So if you put that into your calculator, it would give you something really close to the whole height of 693 feet. And then we have one more. It says a rocket is launched from a tower. A height of the rocket is related to the time after the launch. Using this equation, find the time that the rocket will hit the ground. So x is seconds and y is height. So we want to know, when is it going to equal 0? When is the height going to equal 0? Now we have a way. We could use quadratic formula. It would give you two solutions, only one of which makes sense in this problem because x's are seconds. So we only would be talking about positive amounts of time. Like as time has gone by, a negative x value in this situation would not make sense. So what I would do is go type this into Desmos if you want. You could also use the quadratic formula by hand to get the solutions for what x would have to equal. If I were to go to the graphing calculator here, hopefully it's going to work for me today. That would be crazy if it didn't. Okay, I'm going to type this in. Y equals negative 16x squared plus 266x plus 102, and I hit enter. And I'm going to zoom out just a bit. I can see that it happens twice. It happens once at negative 0.375. That is a x value that does not make sense as far as time goes. So I'm going to go ahead and go to the other one, and I can see that that's 17.0. That makes a lot more sense, that 17 seconds after the rocket launches, it lands on the ground, right? So we should have gotten negative 0.375 and positive 17. Positive 17 seconds would be the best choice. And that was a whole number, so we did not have to worry about rounding. And that is it. See you later.